So our next problem is, how many numbers up to 500 are perfectly divisible by 2? Okay, how many numbers up to 500 are perfectly divisible by 2? So which means that from 1 to 500, how many numbers are exactly divisible by 2? Okay, let's take a simple example. Suppose when I ask you that, how many numbers up to 20 are perfectly divisible by 2? How many numbers up to 20 are perfectly divisible by 2? Suppose if I write all the numbers which are perfectly divisible by 2 up to 20, those numbers are what? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, right? So now we'll count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how many numbers we have? 10. See, if you observe the complete sequence, we take the difference of 2, right? So which is nothing but after every 2 numbers, we'll get the 2 multiple. So can I say that without writing all these numbers, see this 20, when I divide with 2, the quotient part is your answer, q is equal to 10. Can I say that the 10 numbers are up to 20, 10 numbers are divisible by, perfectly divisible by 2. And similarly, suppose if I ask you that how many numbers up to 25 are perfectly divisible by 2. So now I'll just add some more numbers to the list. So 22 and 24. I can't write 25 because 25 is not divisible by 2, right? So now what will we do? So again, since it comes after every 2 numbers, so which is nothing but I divide with 2. The quotient is what? 25. 25 and I divide with 2. The quotient part is what? 12. So the answer is what? 12. So here remainder need not be 0 because only we are taking up to 20. So since I am taking 24, I am not taking 25. That's why we'll get remainder 1. So that's why we never bother about the remainder what we get. We always look for the quotient. What is the quotient we'll get? So this is the concept behind finding out the number of numbers up to a particular number divisible by another number. Okay, it's a very, very simple concept but very, very important topic in the exam. How many numbers up to, now the problem, if you see the problems, how many numbers up to 500 are perfectly divisible by 2? And for any kind of, for any problem related to this kind of questions, then simply what will we do? We take the given number, divide with this number and the quotient number. Okay, quotient, do you remember that what is quotient? Quotient is nothing but, so the number which comes in this place, right? So here I can directly write the value. What is the quotient? 250. So I would say that up to 500, how many numbers are divisible by 2 is nothing but what? 500. So answer is what? So the answer is 500. So let me give you one more example. So if I ask you that how many numbers, let's say that up to 350 are perfectly divisible by 3. If I ask you that how many numbers up to 350 are perfectly divisible by 3, then it is simply what? Divide the given number up to how many numbers we are dividing, how many numbers we are taking, divide with this number and the quotient will get is your answer. What is the quotient will get? 3 ones are 3 and 3 ones are 3. So 2, 3 16s are. What is the quotient will get? 116 will get. So you divide 350 with 3. So 3 ones are 3 and 5. So 3 ones are 3. So 2. So 2 6s are 3 6s are 18. So the remainder is 2. So the remainder part is not important here. So I am telling you that the remainder is not important here. So the only thing is important we are considering is the quotient part. So when I divide 350 with the 3, the answer is what? 116. So up to 350, how many numbers are there which are perfectly divisible by 3? There are 116 numbers which are perfectly divisible by 3. Okay, so you can find out any question answer by using this one. Simply divide the given number with the divisible number. Okay, let's take another one. How many numbers up to 1000 are perfectly divisible by 7? How many numbers up to 1000 are perfectly divisible by 7, which is nothing but how many numbers are from 1 to 1000 are perfectly divisible by 7. What will we do? We will take the main number, divide with this number. So this number is divided with this number and the quotient obtained is your answer. what is the quotient we are getting here? See, so 1000 divided by 7. What is the quotient part we will get? So 7 1 is 7, 3, 7 4 is 28, 2, and next 7 2 is 14. So what is the answer? So the answer is 142. So 1000 when you divide with 7, the quotient part is your answer. Just simply like this. If you can't divide directly, so 7 1 is 7, so 3, 7 4 is 28, 2, 7 2 is 14. Right? So the remainder is 6. As I already mentioned, that remainder is not important. That so which means that we have further, if I have left with 6 more numbers in this list, so that is not important. Only take the quotient part. Okay. So how many numbers are there up to 1000 are perfectly divisible by 7? That is, there are 142 numbers. Okay. Let's take the next one. How many numbers up to 900 are perfectly divisible by 12? Again, the same model we have. So take the number. What is the number? 900. Divide with 12. And the quotient part is your answer. Quotient part is what? 12 7 is 84. So 6 remainder. 12 5 is. If I divide 900 with this, 75 is the remainder. 75 is the quotient, and the total number of numbers up to 900 which are perfectly divisible by 12 or what? There are 75 such numbers we have. And remember that, so we don't need to bother about the remainder. Remainder need not be equal to 0. Okay, is it clear? And when we go to the next type, okay, the same type of model, say in the same list. So instead of dividing with the single number, suppose if I divide with 2 or more numbers with a condition of n, then how do you find out? See, up to previous problem we are divisible by a single number only. Up to previous problem we are divisible by a single number. We are just checking the number, right? But if I ask you that how many numbers up to 1000 are perfectly divisible by 5 and 6, that means that here we are not dividing with a single number, we are dividing with the multiple numbers. Okay, let me elaborate it by taking a simple example. So suppose up to 30, if I ask you that how many numbers up to 30 are perfectly divisible by both 2 and 3. Both 2 and 3. How many numbers up to 30 are perfectly divisible by both 2 and 3? Suppose if I write separately, so how many numbers are perfectly divisible by 2 up to 30? So 2 2s are and 4, 6, 8, 10, 12, 14, 16, 18, 20. Let me write all the numbers: 22, 24, 26, 28, 30. So how many numbers up to 30 are perfectly divisible by 2? So these are the numbers up to 30 which are perfectly divisible by 2. And also how many numbers up to 30 are perfectly divisible by 3? The numbers are 3, 6, 9, 12, isn't it? So these are the numbers which are perfectly divisible by 3. So which are nothing but the 3 multiples, right? So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Since I am asking it for up to 30, so these are the numbers which are perfectly divisible by 3 up to 30. Right. Now what is our question? Our question is, up to 30, the numbers must be divisible by both 2 and 3. Okay, it is not just enough to divide the numbers with 2, or it is not just enough to divide the numbers with 3. The numbers which we are taking must be divisible by both 2 and 3. Which means that what? I need to take the common numbers, the numbers which are divisible by 2, and the same numbers must be divisible by 3. And which means that I am taking out the common numbers, right? Which common numbers we have? Suppose if I mark them, so 6, and next number is 12, and next number is what? 18, and next number is what? 24, and next number is what? 30. If I write them separately, the numbers which are divisible by both 2 and 3 are what? So 3, 6, 12, 18, 24, 30. So which means that how many numbers we had? How many such numbers? We have 1, 2, 3, 4, 5. So there are 5 such numbers we have. Okay, what is the answer then? The answer is 5. So answer is what? 5. But in the exam, we cannot write all the multiples, right? So because the problem would be asked for up to 1000, up to 10,000. So it is not advisable to write, or it is not possible to write all such numbers, all such multiples, right? In that case, what will we do? Okay, if you observe the sequence, or if you observe the pattern, the logic behind which numbers we are taking, then easily we can do the problem. So if you just carefully observe the numbers, so what are these numbers to the number 2? So these are nothing but multiple, right? First we write all the multiples of this number, this number. For the given numbers, for the given two numbers, we write the first multiples. And then after that, which number I am picking? The common numbers, which is nothing but, I can say that common multiples, right? I am taking only common numbers only from these two lists, right? So common multiples, I am picking up the common multiple. Even again, if you see the least between them, least among the given common multiples, if I take the least common multiple, what is that one? Least common multiple means that LCM. What is that? LCM. Which means that, suppose if I know the LCM of the given numbers, LCM of the divisors, then automatically the multiples of LCMs is your answer, right? Now you see that, so whatever the numbers I am writing for 2 and 3, that is nothing but the LCM multiples, right? 2, 6, 12, 18, 24, 30. Which means that what? Okay, after finding out the LCM of these two numbers, now this complete number, both numbers or n numbers will become a single number. Okay, I'll just write it, I'll put it in this way, and finally, so no need to write all these things. Okay, what is the LCM of these two numbers? So 2 and 3 LCM is 6. Now instead of taking both 2 and 3 separately, so we will take a common number, which is nothing but what? LCM of the number. Now you divide this number with which number? LCM of the divisors. What is the LCM of the divisors? 6. So if you divide the complete number with 6, so the final answer is what? 5, right? The same answer. Which means that what we are doing here, okay, so how many numbers up to 30 are divisible by both 2 and 3? If the condition is, see, just observe that up to previous problem we are dividing with a single number. Okay, the divisor is a single number, so we are dividing with a single number. But if you are dividing, so more than two numbers, 2 or more than 2 numbers, if you are dividing with 2 or more numbers, then you take the LCM of those divisors. Okay, so up to previous problem we have only single problem, that's why we don't have any problem. So we can directly divide the number up to which number we are finding, we directly divide with that number, we'll take the quotient as answer. But here in this case, if we get 2 or more numbers, if you are supposed to find out the numbers which are more than 2 or 2 divisors, then what will we take? We first take the LCM of these numbers and divide the given number with this LCM number, and the quotient is your answer. Okay, let's come to this problem. Okay, so what is that? How many numbers up to 1000 are perfectly divisible by 5 and 6? Okay, which means that first you find out the LCM of these numbers, 5 and 6. What is the LCM? 30 is the LCM, right? Now you divide 1000 with 30, right? So 330 is the answer. So 3 3s are 330s. So what is the answer? Sorry, 1000 divided by 30. So 0 0 cancel. 3 3s are 3 3s. So the answer is what? 33. So the final answer is what? 33. So if the question is how many numbers up to 1000 are perfectly divisible by 5 and 6, the answer is 33. Is it clear? Okay, so I will repeat it again. So how many numbers up to a number are perfectly divisible by, so 2 or more numbers, then the procedure is, first we find out the LCM of these numbers and then divide this number with the LCM of these numbers. The quotient is your answer, final answer. Is it clear? Okay, so here we can have 2 numbers or more than 2 numbers.